director at the Lisbon Council, a think tank based in Brussels and a partner of the project Reinforce. So Reinforce Research Infrastructures for Citizens in Europe is a research innovation project supported by the European Union's Horizon 2020 SWOF's Science Written for Society work program. The aim of the project is to create a series of cutting-edge citizen science projects on frontier physics research with citizen science that will make a valuable contribution in order to managing the data avalanche that comes from the physics research infrastructures. So today we are here running an interactive workshop called Citizen Science and Data Sharing Boosting Large Physics Infrastructure Research. So the idea of the workshop came out from the fact that Europe is home of major world-class research infrastructures, which are basically enablers of research and technological innovation, and also they drive data-intensive science and multidisciplinary science. So these research infrastructures are also very important because they can spread the scientific method in society, and they can provide basically citizens with the intellectual ammunition to become critical consumers of scientific knowledge. But in order to do that, we need to create a well-functioning ecosystem that allows new forms of co-creation among professional researchers and also among researchers and citizen scientists. And the first element can be achieved through opening and making available research data. The second, by empowering citizens not only to access research output, but also to take part in the process of scientific discovery, producing high-quality data and adding to the scientific knowledge. So for what concerns the programs of today, we're going to have a first introduction of the project by the coordinator, Stavros Katsanevas. Stavros basically is the president of EGO and is a project coordinator of Reinforce, and has been basically the initiator of the project and the driving force behind the project. Then we are moving to the first thematic, which is going beyond outreach, citizen science as an effective way of engaging the general public with large research infrastructures in physics. And in these thematics, basically, we are going to have presentations by one of the partners, Linor Kemaniki Agogi, who is also leading basically the second thematics, which is citizen science in Reinforce and formal-informal education. In this second thematics, we are going to talk about the preliminary findings from teacher training and piloting with schools regarding the introduction of frontier science of large research infrastructures to formal and informal education through citizen science. Then we are going to move to the third thematics, how to share and reuse research data from EOSC, and so the European Open Science Cloud. In this basically in this part of our presentations, we are going to have the pleasure to hear from Villette Hunen, who is a data solution architect at EGI. EGI is basically a foundation which is one of the initiators of the European Open Science Cloud. And basically, the session will explore the benefits of integrating the data produced in the project in the EOS infrastructure, and more in general, how to exchange data among large research infrastructures in physics and also to researchers. And then in these thematics, I'm going to also talk about the potential reuse of data from EOSC. In the final session that is going to be led by ZSI, Center for Social Innovation in Vienna, the last thematics is what's in it for a citizen scientist. So basically this session explores the personal benefits for participating citizen science in the reinforced demonstrator projects implemented with large research infrastructures. So it's time to give the floor to Stavros Katsanevas. Please, Stavros, the floor is yours.
Thank you very much, Francesco, for this nice introduction. let me share my screen to try to say a few words. Most of you probably know the things I will say, but I will say them nevertheless. So, what's happening? It should be, come on. Why doesn't?
They're pretty visible, Stavros.
It's pretty visible.
Yeah.
Better now, eh? Yeah, you say it? No, it doesn't.
It's not completely full-size screen, but
Yeah, now it is.
maybe it's coming.
It's okay?
It's still black, actually.
Huh?
Yes, it's black, Stavros.
Huh?
It's black screen.
Black screen. Why is that? I mean, sorry about that. I will try again. Sorry about it, and I'll try again. Okay. And I will share again. Okay. New things happening. Now it's okay? You see it?
Now it's perfect.
Okay, good. Thank you very much. So let me go very fast among things because these are the partners which you see. These are partners from Europe. Some of them were mentioned already. I will not go through them. And we also have the pleasure to have people from Argentina doing a sonification. It's through CONICET, doing sonification issues. Now, what are our goals? Is, as the program says, develop science with and for society. So concerning science, we want to accompany, for instance, gravitational wave and multi-messenger physics, the experiment of gravitational waves Virgo, then kilometer cube, which is about neutrinos and cosmic rays, and essentially through this big scientific revolution we are living, that's called multi-messenger revolution, where we try to understand the universe with many messengers and many links, and we're trying also to strengthen our interdisciplinary links with, let's say, more traditional and also very innovating disciplines, as for instance, particle physics, for instance, dark matter at LHC. Then something that's becoming more and more obvious is that you cannot understand the cosmos as the universe before understanding what happens around you. And this is even more strong as is in the case of the multi-messenger physics. You have to understand, for instance, in the case of gravitational waves, the seismicity. You have to understand the atmospheric effects, the clouds above us. The clouds above us affect the presence of the mirrors, let's say, of the interferometer of Virgo. Anthropogenic effects, society, cosmos as society, and also, of course, do things that I will say further down. Then a third thing that happens is that when you start looking at the universe, not only through light as we were used since highest antiquity, but also with other messengers, and we claim that, okay, we receive gravitational waves and we transform them into a signal, interferometric signal with acoustic frequencies. It is as if we understand, we hear the universe, and then so it is a metaphor, of course. It's as if we were close to two black holes colliding, we would hear it. I mean, our ear would vibrate and we would be hearing it. So this induced us the thinking of multisensoriality. We should not be based on only one sense to understand the universe, but we should have many senses together. And this is how we, for instance, accompany all our demonstrators of and programs that we have about gravitational waves, kilometric cube, that is neutrinos, cosmic rays, etc., with sound. And of course, develop a roadmap with astroparticle large infrastructures. We'll be probably talking about it later on. And then for society, if you do multisensoriality, of course, you increase inclusion and diversity. You go to many things like art and science, and something we need to develop a lot. We haven't yet done it, but hopefully will. In the last 6 months of the project is critical thinking. How do you use your judgment to understand, to distribute between your biases, your proper biases, and what is the, let's say, the things you have in front you tell you, reality, let's call it, and how you manage, let's say, the discussion within a community to go beyond herd thinking towards a collective thinking, etc., etc. All the principles that happen inside science that need also these days to go beyond, to go into society more generally. So I have 11 partners, as I said, coordination, 4 demonstrators that were included in the very well-known program by Oxford called Zoo Universe, a transversal project, which is the Sonification I already mentioned, and then the things we have been discussing about engagement, impact, and road mapping that will be touched upon more in the coming hours. Then we have software tools, we have a presentation, a participant portal for internal communication, and a public portal. So then we have to be careful because, of course, it's easier said than done, this story of citizen science. We have to not make silos to assure close communication with the 4 infrastructure or work packages, avoid instrumentalization of the science of the citizen as, let's say, a simple classificator. I mean, these are companies that do that by using it in the third world, but on the contrary, try to develop the critical thinking, obtain critical feedback. And this is, I mean, this workshop is again in the same logic. And at some point, don't only rely on, go back to the human, let's say, the human qualities, but also mix it properly and at the right level with machine learning and other tools that we need to have. And then, of course, avoid simple illustration and patternism in all the multisensorial art and science and critical thinking efforts we're doing. And of course, we would like to have new audiences in the universe. We try to follow up to understand what and how are people interested in all that, avoid language barriers. And then, of course, we are in close contact with many people in other infrastructures. We had, and I personally had, a lot of contact with essentially all the large infrastructures of astroparticle physics, and there we hope to have together to make a roadmap. And of course, not only astroparticle, of course, CERN, it's another possibility. So only yesterday came up to see why it's interesting. We'll talk very shortly about the glitches, these objects we try to classify in the gravitational wave demonstrator. It came out a paper saying that more and more as we increase the sensitivity of these detectors, we'll see more and more events. And what it is noise right now will be mixed with events. So it will become a very important tool to understand what a glitch is and what form it has in order to have the discovery. So it's not a simple thing. It is something that will become more and more embedded into the analysis of what we do. So, as I said, we are in Zoo Universe. Very, very fast. One of the programs called Gravitational Wave Hunters. And these are the glitches I was telling. These are analyzed in the frequency domain. And there you see these signals, and they have different forms, and the different forms tell us something about what it is and where it's happening. And then you, as a citizen, you want to classify them, and you have different forms that have appeared before in the same detector, and you try to classify them. And not only that, you also try to associate them with other signals coming from what we call environmental sensors around the detector, and therefore see whether you can use, you can correlate, because correlation is behind causality very often, to see what caused what. I mean, try not only just to classify, but also correlate. Then we have the deep sea explorers that are what we said about the neutrinos at the bottom of the sea. And there again, it's interesting because it is a neutrino signal, but it is coupled to the deep sea let's say, environment. For instance, you can have sounds coming from neutrinos, but you very often get sounds simply by the dolphins or the whales. And this is very interesting. We have a lot of data, 10,000 years already of existing data, and there will be many more coming. And there, it is a very interesting, even biological study that can accompany the search of the universe. So you see the mingling of science, or let's call it fundamental in the sense of what is happening in the universe with the environment around us. Then here, I don't know if, I mean, you have peaks, and these peaks are signals, and you identify them and you store them, and this makes it very interesting help for understanding and measuring whether it is a sperm whale, a short-fin pilot whale, pure noise, or something else. Then you go into the particle world. Particle world means trace of things, and then you try to find new types of event. We had recently a lot of new, or let's say, questions that appeared with the new mass of the W and the muons, the muon constant, and things like that. And there are theories that say that the particles we're seeing have accompanying particles that are not yet seen, and they might be products of invisible decay. And it's a very difficult search when you have some particle that does not have a trace, but then decays, to find. And then you do, through different stages, you can measure these things. And I'm not going to more details. And last but not least, we more and more understand that the cosmic rays that pass through our body are a signal of many things, that are a signal, for instance, of the atmospheric changes. Again, yesterday or 2 days ago, a study that says that if you put underwater cosmic ray detectors, you can see destructive atmospheric events coming from elsewhere, from the world, and very far, but coming very, very close. Atmospheric disturbances you can measure because the cosmic rays are affected by our close environment, our atmospheric environment. Again, here, the citizens are helping us to identify tracks and identify these tracks and use their frequency as a signal, for instance, of atmospheric changes. But not only that, you can put it next to, for instance, volcanoes, and try to see whether the there is things happening that might be disruptive, or you can put it inside underground and look at a search from archaeology to civil construction to see the things happening underground. So then, as I said, all of them, we don't have the time, it's not today to present these things in detail. All of these things, we try also to have a sonified version, and we are close to the very final steps to that. And with that, we fulfill our, as we said, our multi-sensorial promise, which is not only to increase inclusion, and it certainly increases inclusion, but also increase our capacities to understand better in all senses, let's say, the universe that surrounds us. And there we have the help of, for instance, also here in EIGO, we have the help of Wanda Diaz-Merced, a key person for the sonification of events. Again, for instance, these glitches can be sonified, as I said before, because they are in the acoustic frequency range. And very soon, for instance, one of the things that this will have to have when we organize also things in presence. We're finishing it's a matter again of 1 or 2 weeks, a multisensorial telescope that we hope that we will show in one of the schools happening in Greece that Rainforest supports, where, for instance, you look at the moon and you don't look only at the differences of light and shadow, but they are immediately translated into sound and even vibration. So you can touch up some kind of pad and feel the vibration of the moon, if you can say. So then many things that we're doing around to enhance our participatory engagement activities, science cafes, exhibitions, webinars, etc., and virtual visits and challenges and art and science, as the Cosmic Concert we organize, also with the help of Barry Barish, the Nobel Prize on gravitational waves, and many other things, and many deliverables. And we try to monitor all this closely to see whether we lose the attention, because that's one of the issues. Usually citizen science, to get first people that are attracted and then slowly lose the fidelity, if you want, of the people. So we try to keep that alive, and by many, many ways, and which you probably hear later on. And we are, last but not least, I think we are in the steering committee of the International Year of Basic Sciences for Sustainable Development, which is an UNESCO program, a United Nations program, and where we will certainly we have not yet fixed the date, but must be somewhere between October and November this year, a big workshop on exactly what I was proposing all the time, how the science of, let's say, call it fundamental, is embedded in the environment. And it's not only its impact, it's CO2, etc., that you have to measure, but also it is with all these sensors, you would try to also contribute to resolve issues of climate change and things like that. For instance, the formation and the movement and all that of the clouds is still one of the big problems of how you measure climatic change. And for instance, we said that with cosmic ray detectors, we can monitor that. Why not have distributed this all over the world, in schools and everywhere, and people would participate somehow in the monitoring of that, and eventually have a have some prediction about how these things happen. So as I said, we hope to start very soon with Sol Permuter, the Nobel Prize critical thinking courses. We will have distributed and improved apps, and we are collaborating in a program we also submitted to the European Union with a Polish group called Credo, where they have an app for distributed ultra-high energy cosmic ray sensing. And we want to specialize interactions by making PCs already in 2 weeks from now. We will do something nearby, for instance, here in Italy, and construct distributed sensors for use in schools and elsewhere, move from the software to operation. And then another very ambitious project where we collaborate very well-known artists worldwide with huge exhibitions around the world, Thomas Saraceno, where you link, why not, to traditional knowledge people that, you know, they had their methods of saying that something is coming, some bad weather is coming and things like that. And by talking to them and trying to revive this relationship of how people felt that something is happening, try to mingle the sensor, what called scientific sensor logic, with the traditional sensor logic, and extend this not only, of course, to humans, but also to, let's say, even animals, how they sense the changes that happen in their environment. It's a very ambitious project. It can start as art and science, but then you never know what happens, and you start having a lot of articles, even in very serious newspapers, or not newspapers, sorry, periodicals like Nature, for instance, about these things, and people start getting attention to that. So this is what I wanted to say as introductory material, and thank you very much for listening.
Thank you very much, Stavros. This was very informative, as usual, very interesting. So I now give the floor to Elinor Germanikia-Gogi for the thematic one, going beyond outreach. So the floor is yours, Manolis.
Thank you, Francesco. Let me share my screen. Can you see it?
Yes.
Perfect. Very well. So together we will discuss about our approach in actually bringing citizen science closer to education in the fields, the topics that Reinforce is all about. So I will go a few steps back, and I would like to discuss a bit that we have the rationale for this. So we know very well that we have game-changing discoveries in the frontiers of physics, let's say, from the discovery of gravitational waves to the discovery of the Higgs boson, to the first neutrinos from a blazar, okay, to the first attempts to understand the innards of a pyramid through cosmic muon imaging. And all these activities have great media coverage. All these discoveries have been very, very widely disseminated in the media. They also have spin-off or direct impact to technology and society. For example, here you see the Fukushima Daiichi as it was, let's say, monitored through muons, through muon detectors that were placed around it. You know, a non-invasive technology to map the inside of the building, which is actually what cosmic muon images demonstrator is all about. The impacts of large research infrastructures have been very well documented, and they are continuing to expand on and on. We may all know that the World Wide Web started from Tim Berners-Lee at CERN. We all are also aware that proton therapy, for example, uses accelerator technology, which has been developed for fundamental physics. And of course, we are all aware maybe about the knowledge transfer initiatives through which discoveries in fundamental physics that translate, let's say, to industry and society, to innovations there. However, as science progresses, on the other hand, we have great outreach initiatives to communicate these activities to the public, from master classes to site visits, to talks, public talks, to science museum activities, and so on. And these have a documented impact, even though they are mostly one-off for some people, meaning that this is one of the greatest problems in outreach. You can see here, for example, this was a few years ago in how many countries the physics master classes had expanded into. And this comes from a paper here saying that how students, let's say, interest increased about physics after attending master classes, or how they required more modern physics at school. But again, frontier physics and its impact are not introduced to school curricula. And, you know, students may be able to learn about new discovery from media, but teachers are not always prepared to answer these questions adequately. There is also a lack of a feedback mechanism, a systematic communication between educators and researchers, as well as between educators with the same passion for introducing these topics to the school. Okay, this is one of the most important, let's say, drawbacks in the field of outreach. There are other factors that contribute, for example, teacher training or educational content and so on and so forth. But the thing is that what we identify right now is a gap. Despite the fact that we have these activities there, we have this knowledge, let's say, gap and practice gap between cutting-edge research in physics and school education. So, according to Chris Impey in 2012, higher scientific literacy can lower an individual's susceptibility to anti-intellectual beliefs. So, beyond teaching new content knowledge, let's say, we believe that the introduction of these topics to students, actually, it's not just that they learned about relativity or the Higgs boson or how a gravitational wave detector works. It's about learning and immersing themselves in the culture of science as it is being done right now in large research infrastructures from large international collaborations. So this is something that we hope to, let's say, help somehow.
Sorry, Manolis, for interrupting you.
Yes.
We have a comment in the chat that the people can't see the current slide. Can you change in the presentation mode? Because we still see only the first page of your presentation.
Oh, seriously?
No.
Okay, apologies for that.
Mm-hmm. Okay, thanks.
Apologies for that. Yes, so yes, I will do it right now. Should I show the images briefly, or should I proceed? So again, apologies again. So again, we have these great discoveries with the media coverage and the impact to society, as we discussed. And again, despite the great outreach initiatives, we have this gap that we identify. Okay, so according to research, this let's say immersion, this connection between school and research, these sustainable links could actually help, let's say, lower an individual susceptibility to anti-intellectual beliefs. So, to our understanding, it is paramount that the research and educational communities do bridge the knowledge and practice gap. And we believe that we should support students towards an increased understanding of and participation in science. And how do we do that? For Rainforce, citizen science is the glue, let's say, that will be able to bridge the gap between large research infrastructures and school education. How will we do that, or how are we actually doing that? From the one hand, large research infrastructures can do offer authentic research experiences for students. They help increase relevance and meaning of school science. and they support the increase of students' science literacy. Again, not only in terms of content knowledge, okay, but in general, in terms of students' science capital. This can be discussed later if you like. On the other hand, how can students help? Students can actually contribute in the production of new knowledge through citizen science, because citizen science demands, as you saw from Professor Casaneva's presentation before, not elaborate tasks necessarily. Tasks that with proper guidance, students can be led to do themselves, and they can actually discuss and have feedback from researchers in the field. This contribution could actually help support the optimization, let's say, of a research infrastructure. And they could also help raise awareness, acting as multipliers, both teachers and students in these topics. So, students as citizen scientists, why? Let me share my screen and show you a very short video that actually I find very inspiring. I will switch on the subtitles and I will share computer sound. Okay, so let us enjoy this little.
And I'm Mia. We're here in Hampton Hill School in Tawa. We're here to tell you more about online citizen science. So, what is online citizen science?
Okay, online citizen science is where the scientists have gathered a whole pile of data, and then they use citizens to help analyse the data. And being online, anybody can do that. And that's where it's really cool in the classroom, because we can actually get out there and help the scientists, even though we're not trained and we don't have all the degrees and everything needed, but we can still help them out.
Can you give us some examples of this work?
Okay, what we're doing with our one is we're looking at the skink spotter, and we've been finding out all about the Otago skink and how it's endangered, and it's in a couple of locations in Otago, and we're looking at what the habitat, what they like, who their predators are.
We saw skinks and rabbits and birds and predators and lots of photos with nothing in it.
They come out when people are not looking.
We're learning more about skinks and we're being involved in science.
Got it, but are you sure? Yeah.
It has been discovered that adults who were doing this, they were actually learning quite a lot. So we then ask ourselves the question, okay, if adults informally pick up that knowledge, does that happen to kids as well? So if children participate in that, would they learn something about the science behind those subjects? Would they get interested in science?
It makes me appreciate what scientists do more.
It's quite cool doing the real science.
I was quite enjoyable because you were engaging in real science and you knew that this had a difference in the world.
What have you learned?
So going back from there, the messages we have gotten from the kids here is that it is actually helping them to increase the sense of meaning in the science they learn. They may not be able to learn the full science content of, for example, the discovery of the Higgs boson. Actually, it needs a graduate student to be able to understand the Higgs mechanism. But they can learn a few things about how CERN works and how we detect particles. They can communicate with scientists. And this is what is important for us right here. So young people in general seem to struggle to see the relevance of what they are studying. And what would happen if the data they collect from an experiment in the school lab could be preserved because it contributes to scientific knowledge? Imagine that. Imagine that except for doing the school lab for education, measuring the period of a pendulum over versus its length, for example, you could also additionally work a little bit with CERN scientists to classify events and help them understand their detector better. In one case, it has a great training value. In the other case, it can also contribute to science. So what if this could actually work? For us, promise of citizen science for schools is a win-win, because students get authentic access to science And scientists, on the other hand, get many enthusiastic volunteers along with leaders and data quality filters, the teachers. So for us, students are envisioned to contribute in the optimization of large research infrastructures in physics in the end, hopefully through their work, to become partners in the research enterprise, to increase the sense of meaning in school science. We hope to help them increase their disciplinary knowledge and their overall science literacy. And we definitely believe that these activities could actually help them increase their science motivation. So what are the challenges? What are the doors, let's say, we need to open? First of all, the key issue when we introduce new physics to the school curriculum or new science in general is that we go beyond what the curriculum is. So this is our main challenge, either we do citizen science or not, or doing outreach. Secondly, we need to balance scientific goals and learning outcomes. As Professor Casaneva said, we don't want to make citizens and students in particular classification machines. We want them to contribute and we need their input in order to do science. But on the other hand, we want them to learn. And this balance is one of the key, let's say, challenges that we have in school education. The third one is the lack of teacher training and support, and this is one of our, let's say, bets here. And of course, it is the classroom reality, which says that due to the curriculum pressure and lack of classroom time, it is, for many countries at least, it is very, very difficult to take these topics and teach them and mainstream them in the classroom. So we need to find ways to do that. And what are the desired learning outcomes for our students? It is project-specific learning outcomes, for example, to learn what a glitch is and how it relates, let's say, to its potential sources. It is disciplinary knowledge in general, for example, understanding about how an interferometer works or how wave interference works in the scientific literacy, and also personal development, expanding interests and social networks, potentially identity change with respect to how we perceive ourselves compared to science. So, what do we do in order to overcome these challenges? The first step is the design of pedagogical approach and rich educational resources connected as much as possible, I would add, to the school curriculum. Teacher training and vision building, practice in real school environments, and reflecting on practice and incorporating feedback. So you can see all here in a nutshell. Okay, you can see the problems, you can see the, let's say, proposed solutions, and you can see the goals. So, in terms of pedagogical design and educational resources, the Rainforest team has decided to adopt an inquiry-based approach, okay, which follows, let's say, 5 specific steps in how we design our resources, after all. And we have developed a set of educational resources for all activities, for all demonstrators that we have, to flank them and to, let's say, give us a way to present them in the classroom. And you can find everything in our platform. I would like to take some time to give a quick example about gravitational wave noise hunting based on G-Witch hunters for schools. Okay. How do we orient people? We introduce gravitational wave astronomy and detection methodology. Okay. We do that by using simple experiments to demonstrate the principles. Also, we incorporate activities from informal learning. For example, virtual visits to Virgo or to CERN or to Kérosé. We have done this with students in general. We use, this guy is me, we use simple instruments, simple, let's say, experimental setups to help students understand the detection mechanism here. And of course, we give them the opportunity to interact with researchers face-to-face before we start the work, because we want them to understand what this is all about. If they don't have an idea about the science, and to get, let's say, some concrete steps to to give them this understanding. We cannot ask them to do any classification. They will not understand what they are doing. So the second part about the problem identification is for students, in this case, to understand the problem. What is the problem? Noise. So we need them to understand noise through an analogy, because signal and noise are usually not taught in the school curricula. So when they understand that gravitational wave detectors, for example, can act as a very big ear, let's say, which is sensitive to understand specific sound patterns from very far away, we also can help them understand that the environment in which the detector is embedded is actually contributed to the noise and therefore our sensitivity to detect the signal. Okay, and there are sources of noise that are understood, for example, but there are other sources of noise which are poorly understood, and these are called glitches. Okay, and so therefore we have a challenge. The challenge is that to understand glitches, to understand the, let's say, origins, we need to classify them, let's say, okay, to find different categorizations of them. And in that, the human, let's say, observational skills can actually may prove superior or complementary to the computer algorithms that are being implemented. And this is where citizen science comes to the rescue. So we explain what a glitch is, these noise triggers that introduce dead time in the detector, and we may not know their origins. This is what a glitch looks like, and you see here, and this is superimposed with the actual detection of a gravitational wave in LIGO, and you can see this is the rare thing. This is what introduces dead time in our detectors, and so this is what we need to control and understand in order to be able to observe this successfully. So the pedagogical design continues with investigation and analysis, and you will see that in all demonstrators we are using educational data sets, let's say, to train not only students but citizens overall to understand actually what we do. We have the playground here, for example. Okay, and then we proceed to the classification of gravitational wave noise data. The final part, which is the communication, which is to me the most important thing, is that we need to give the students the understanding that what they do is not something that they do once and then they leave. We are here to support them. And to support them, we need to have the framework, let's say, to have the platform, and to have the people who will be there to discuss with them, to guide and support them. And this is what Zooniverse actually has a unique added value compared to any other initiative that I know of, because it actually gives us this opportunity. The researchers are there, they are discussing with people. So here we give, let's say, an insurance, an effective insurance to students that if you want to continue, please do, and we are here to support you. Okay. So this was an example of a resource, and what we have done in great, let's say, detail over these years was teacher training and vision building of teachers, mainly because for us teachers are the multipliers who can bring these activities to the school community, and they are the people who can help us understand students even better. So this was a program, and this I will briefly give you some feedback on what the teachers understood about the Rainforest Citizen Science activities in education. So the Rainforest Citizen Science activities, according to teachers, might not be that relevant to students' life, but they can increase their collaboration. Students, they can be enjoyed by them, and they can increase their sense of meaning of learning and science courses. This is the bet for us. And what are the challenges that teachers have identified? Curriculum, lack of resources, lack of training, and potentially lack of infrastructures. And what are the critical, the desired learning outcomes that one would intend for the students? Cooperation and critical thinking. These are the things that teachers have actually shared with us. And this is, we built on that, we designed on that. So the third step was practice in real school environment. And as you know very well, the coronavirus actually didn't help us a lot in this sense, but online tools actually allowed us to be able to do this. So you see some screenshots from online workshops we did with schools all over Europe. Here is from the High School of Xanthi in Greece. And this is from two schools, one in Rodolivos in Ceres and one in Thessaloniki. And also, we have also done activities face-to-face with the students. Always face-to-face is more preferable if it can be done, but online activities again can help us a lot. So again, you see that these activities were quite balanced. Students were introduced to the topics, they discussed with the researchers, and they did classifications. So I actually like this blackboard and I wanted to share with you. So finally, I would like to discuss a bit our future steps. In Rainforest, we are organizing an international training course for teachers this July, and you can find more information here. We are continuing and we are planning our final set of implementation activities with high school students. And also we are preparing a series of colloquia for university students this coming period. Finally, we are preparing an online training course for pre-service and in-service teachers. And we are now getting the feedback from students and teachers with whom we have collaborated, and we are starting our analysis. So I would like to thank you, and if you have any questions, please don't hesitate to ask. We renew our
Okay, thank you very much to Manolis. But actually, we are quite ahead of time because I think that you also took care of thematics too. So citizen science in reinforced and formal informal education. So I think that at this point we can move to the presentation by Ville Tehonen, who is going to present the EGI services within the scope of EOSC.
Yes. Good morning or good morning, everyone. Yes, my name is Ville Tehonen from EIG Foundation, and I'm working as data solutions architect there. And my presentation, I will share my screen. Wait a moment, it's here. Yeah, here you can see the presentation, hopefully. And now it's in full screen, I think. Okay, my presentation is about EGI services and computing landscape, and agenda include also some examples concerning about containers, cloud integrations, or EGIA's projects, or they are something how we try to describe how we are working and how to do it, and also some modern architectural ideas, how this kind of federated infrastructure works with the project and different kind of user groups and users and so on. But first, a couple of words about EGI Foundation and EGI Federation. Our vision is that all researchers have seamless access to services, resources, and expertise to collaborate and conduct world-class research and innovation. And our mission is to deliver open solutions for advanced computing and data analytics in research and innovation. So we are working with the research world and also with the innovation innovation world, like digital innovation hubs and similar. And our history comes from scientific computing, but nowadays we are working with data and data analytics, open data, fair data, sharing data with different ways and so on, because these are nowadays combined, and I have a couple of examples there. Our headquarters is located in Amsterdam, and in our council there is 27 partners, members from 21 countries, 5 international research organizations like CERN from Switzerland and ASCAT from Sweden and so on. We have also one representative one institutional representative. We have 2 kind of members. We have full members and then associated members, and 2 of them are, 2 members are associated ones, and from Ukraine and from Switzerland. Basically, we are working, we have a different kind of memorandum of understanding all over the world, in Asia, from China, Korea, and so on, and then also in Americas, Canada, and so on, and nowadays also with some African countries like South Africa, what we can see a little bit later also. Our service catalog perhaps gives some understanding what we are doing and what we are delivering. ETI is a federation, so it means that we do not have our own data centers, physical data centers, but we have members, and we have this federation where is participants who had these resources, and ETI organized the architecture, and we deliver these services to our users, like projects and other user groups and so on. Yeah, and research infrastructures also. Computing services is one main block of our services. There we are nowadays doing cloud computing pretty much. It's about running virtual machines on demand with complete control over computing resources in different places. Then nowadays a number of projects use containers like Dockers and so on, so we can organize all the services above the container architectures. High throughput compute, when you need very much computing power, then high throughput compute is the answer for that. We do not have this kind of supercomputing resources in our federation, but we have also connections to this kind of infrastructures, and we have a collaboration project with them and so on. Workload manager, when you have a number of different things and number of bigger workloads, you have to manage them in an efficient way, so we have tools to do that. Another part of the services is storage and data, and currently we have online storage, which is normally connected to the virtual machines or containers, and we can share the storage capacity via these services. Data transfer is a very important service when you have large data sets, like physicists have sometimes, and CERN has this service coming from also from CERN, that there is a large data sets or very huge files or something, and then you need controlled way to transfer this kind of data from one place to another, and we have also tools for that, because they have to take care of corrections and so on. Then there is a need to share the data with scalable way with other groups or other researchers or other users. Then we have a data hub service. It's based on one data technology, and we can organize access to the data via this data hub, even if it's a sensitive data or just a large data set and so on. And we can organize this access to data globally, so you do not have to be only in the on university. And for that, we are using EGI check-in service, which is this kind of federated AAI, access and authentication infrastructure, which means that you can use your own credentials to access some resources from the federation. Then we have applications on demand, like and the notebooks, where you can create use online applications, and you can create some applications and scripts and live code via notebooks, and then run in our cloud computing resources, capacities and resources, and then store the data into the online storages and so on. So there is a possibility to manage whole development life cycle of this kind of applications. Then we have a few training services like FitSM, which is in the IT management standard, this FitSM, and we can organize trainings on FitSM. We can organize also ISO 27001 training, which is information security management standard. And we have this kind of training infrastructure where we can organize dedicated computing and storage trainings. EIG Foundation is we hold two quality standards, and ISO 9001 and ISO 20000, which are quality standard, and it means that we are working based on these standards by ourselves. Our cloud federation, as on one example, we have 27 cloud providers all over Europe, and as I mentioned earlier, we have some connections to China and South Africa, and then there is also a connection with Canada and some other countries. It means that if there is a European-wide project, we can deliver resources from different countries and organize different things in different places if needed, and so on. Of course, there is a local intentions and funding mechanisms and so on, but we can take care of all these kind of variations between different country management habits and so on. Our cloud capacity consumption trends, if we just look some curves, it means that what is the curve to increase our services, our usage of our services? EGI have had a couple of flagship projects earlier, and the first one was from 2018, EOS Hub project under the European Open Science Cloud umbrella, and there we delivered also cloud capacity for users and research project. And beginning of the 2021, we started the latest flagship project called EGI ACE, and during 21-22 we have increased 60% our cloud capacity consumption within this project, and it means that we are delivering from our federation 43 million CPU hours during this period. The architectural point of view, how we are working, what is our current understanding about this architecture and landscape? It goes that way that we are working more or less. We are working with the project. We are working primarily with research infrastructures, and of course we are working with some research project and so on. And we are working for for example, other European Open Science Cloud partners and projects. First, it means that, okay, nowadays number of different things are organized by this kind of data spaces and thematic data spaces, for example, high energy physics and marine research and so on. Of course, there is early adopters who are doing something which is not organized already in the data spaces, so which are very interesting one because they are upcoming data spaces in the future. Then these are those interfaces where users can use those capacity services, which is coming from the infrastructure or federation. Then there is a different kind of platforms like computing, cluster deployment, AI trade, distributed AI training, workflow management, how to handle and manage all these services and resources. Then we have a federated access to different kind of resources like computing, federated data, and federated identity. This means that, okay, there is not singular point for the data, but we can organize data coming from different sites all over the Europe and so on. Same things with the computing and federated identities, more or less this EGI check-in, where you can use your own affiliations and passwords and usernames and so on. Then there is federated resources from clouds, public clouds, high throughput computing, how performance computing and so on. All these things has been managed by different tools and processes, policies, and we are using those FITSM processes, for example, to manage all these things and these standards and so on. So we can keep all these things in organized and under control. Containing computing EGI, very shortly about these things. There is for example, in the high throughput computing, there is different kind of Dockers or containers used, like a uDocker and then some Singularity and so on, which are available at most sites. It's possible to users that, okay, they do not have to start to build this infrastructure at once, because there is this upper layer of the architecture, and use these cloud manage this cloud via Docker and Kubernetes and this kind of tools. There is also possible to use elastic cluster management and so on. Cloud integration program. This is one example that, okay, again, that where users comes to those resources. We have an EGI check-in, and there is a single sign across the services, which I presented earlier, and the providers, where we have a multiple 27 cloud providers all over the Europe, and then we can use EGI checking to organize access for the users to those resources. Data Hub is the example of the replication of the scientific data to national clouds. So we can replicate data from different cloud to another and hold all those users in under control with the EGI checking that there is those access rights are correct and no one can see something data which he or she shouldn't see and so on. Application database is a distributed distribution of applications and services to the national clouds. We have this kind of application catalog, and you can select the applications how you would like to use this data, and then you control. Then we can control with the users via EGI checking. EGIA's project is one example where we have organized this architecture for different kind of use case projects, and there is open calls for project. It's open, I think, all the time, and it's possible to have some resources paid by EGIAs. And there we have organized that lead experts, and we help those use cases to organize, for example, artificial intelligence application development with our experts. They are coming from EIG Foundation, or they are coming from EIG Federation, which means that there is multiple sites and countries who can deliver this expertise for these use cases. Training program is one part of the ETIAs, and we deliver the user documents, and we have pretty much documentation concerning about our services, but also these technologies and how to use them and so on. And then we provide service and specific support, so our own help desk infrastructures are in use for the ETIAs use cases. And last slide from us today is that it's about the science community services from ETIAs and data spaces. As I mentioned earlier, history of the EIG Foundation comes from the high energy physics and physics, but nowadays we are working with a number of different disciplines and number of different kind of research infrastructures or data spaces and so on. They are coming. Health and medicine is one part, humanities, climate research, environmental sciences and energy and physical sciences and so on. But nowadays all these disciplines are discussing with each other also, and there is a common project with the also with the different disciplines and this kind of federated working model which EIG Foundation and Federation organized is very suitable for this kind of project and infrastructures, and we are trying to support this kind of, how can I say, happy collations where you can find new ideas when something comes from the one discipline and goes to another. Yes, I think that this was my last.
Thank you very much, Ville. Is there any question for Ville? Any question from the audience? Okay, in this case, I will just briefly talk about some initiatives that are related to citizen science that are very interesting also for our Reinforce project, and that can be for sure a little bit studied more in details in the few months that remains until the end of the project. The EOS portal catalog and the marketplace contains several services for citizen science. An example is the service developed within the scope of the COS for Cloud project. So the project is, the title is Co-Designing Citizen Observatory Services for the EOS Cloud. So basically this project targets three main types of users: citizens and citizen science who collect data that can be reused, that are valuable; researchers who use and benefit from the data collected by citizens via smartphones and sensors; and finally software developers. So basically, the idea of the project stems from the fact that currently there are thousands of citizen science applications constituting, let's say, a fragmented ecosystem, a fragmented environment. So in this sense, its app comes from their own login system with a separate database accessible to specific group of researchers. In this sense, also the app are still in app stores, and they are created only with the purpose of the project. So basically, it is frustrating and time-consuming to use the applications in such disaggregated matters, and in fact, an integration service is what can put some efficiency in the use of these applications. The proposed solution is called It's called MOBIS, Mobile Observation Integration Service. And basically it provides a service that makes it easier to gather all kinds of data and keep them open. So basically MOBIS collects and processes data from different mobile observatories that can be, for instance, from smartphones or from sensors. And it can be used as a backend service for citizen science application, science app with a single login. So basically the final aim for MOBIS is to become a large repository for citizen science data, including also data from air, water quality measurement, pollution, biodiversity. And in this sense, there is a combination of a multitude of heterogeneous data. And the service offers interoperability with other apps and takes care of GDPR compliances. Another very interesting initiative is the relationship between ESCAPE project and EOSC. So basically, there is a critical question of open science and the long-term reuse of data for science and for innovation. So basically, the ESCAPE, which is the European Science Cluster of Astronomy and Particle Physics as research infrastructures, it's basically a European world's leading infrastructure that wants to find common solution to the challenge of data reuse, their interoperability, and their access. So the ESCAPE services will eventually contribute to EOSC, the European Science Cloud, implementing a mechanism for a migration of services, which is called EOSC Future Projects. So within ESCAPE, there are two large science projects that are dark matter and extreme universe and gravitational waves. And basically, those two projects are implemented with the objectives to demonstrate new cutting-edge capabilities, especially involving inter-research infrastructures, collaboration, and science outcomes, to validate software tools, services, and infrastructures developed within ESCAPE, and to provide feedback to the ESCAPE project and at the end to the EOSC community. So more specifically, there are a series of ESCAPE services that will be integrated in EOSC in the future. So there is the ESCAPE Data Infrastructure for Open Science, DIOS, which is an applied analytics solution and federated storage service. There is the ESCAPE Virtual Observatory, that is a set of data sets that will be published. There is the ESCAPE Open Source Scientific Software and Scientific Repository, which is a software catalog that will be integrated in EOSC. The ESFRI Science Analysis Platform, which is an analysis environment, and ESCAPE data mining and the management analysis of large-scale data mining, ESCAPE Citizen Science. So the idea basically is for the project ESCAPE to provide those services into EOSC in the future. There is the possibility in this sense to integrate probably also data from the demonstrators that are produced within the scope of Reinforce, to integrate those data in the future within the scope of EOSC, or in any case to have some stronger relationship between Reinforce and EOSC in the future. Is there any question, any observation from the audience or from the other speakers on that regard? Okay, so in this case, I think that we can go for the last sessions of our workshop, which is going to be led by ZSI, and is titled "What is in for citizen scientists." And therefore, I leave the floor to Elizabeth and Claudia.
Thank you very much. I will try to share my presentation. So I see that I have to change the screens. So it should work now. So you see now the slides in full screen, right?
Yes.
Okay, thank you very much. Yeah, my name is Elisabeth Unterfrauner, and with my colleague, Claudia Magdalena Fabian, we are responsible for this session now with the title, What's in for Citizen Scientists? And we have also invited a colleague, Enzo, who is one of the researchers who has implemented one of our 4 citizen science projects or demonstrators, as we call them, the deep sea explorers that Stavros has already introduced. Claudia and me, we are working for the Center for Social Innovation in Vienna, Austria, short ZSI, and we are responsible and reinforce for the impact assessment. So the question, what's in for citizen scientists, is at the very core, at the very heart of any citizen science project. And here by citizen scientists, we mean the volunteers. There's some confusion also about terms and how to call them. We call them citizen scientists, but to make it clear, it's the participants, it's the citizens in the citizen science projects, as we call them. So a brief overview about the session. We will have a very short interactive exercise using Mentimeter in a bit, and then I'll hand over to Enzo to guide you through the deep sea citizen science project on Soniverse, the platform, citizen science platform that we have used for all of the 4 citizen science projects. And then we'll share with you how we have set up the evaluation design. So what do we want to capture in our evaluation, and how do we have operationalized these dimensions in different evaluation instruments. And we will share some first results. And if time allows, then we have another short exercise regarding policy recommendations. So, but now I'll hand over to Claudia, and I'll share now, instead of the slides, I will share a Mentimeter.
Yes, hello, here's Claudia. As Elizabeth already told, I'm a colleague from her, and we want to do a small Mentimeter exercise with you. So I shared the link in the chat. I hope you can access it. And if you do it, then you will have the first question: have you ever participated in a citizen science project as a volunteer? So we give you some seconds to answer this question, and then let's see how many of you have done this so far. And please, everybody should join, even the reinforced partners in this discussion group.
Maybe I've deleted some of your answers already, because now when I logged in, I saw, oh, there are some answers already. So please, in case you voted slightly before, then please vote again. So we have also your answers.
Okay, looks quite interesting. So we see there are quite some people who have already participated as a volunteer in these projects. That is cool to see, because we thought first that only researchers were participating, so that's good. Elisa. So then we go to the next question. Have you ever participated in a citizen science project as a researcher? Please vote again. Okay, it's interesting. So also as a researcher, we have some people here. Good. Okay, then let's go to the next question. So, and now you can type in some keywords. What do you think that volunteers can learn in a citizen science project? You have the possibility to write in 5 keywords which you would like to share with us. So let's see. We should get now a word cloud. Ah, good. It's transforming. You see, here are some quite interesting words: critical thinking, knowledge, science, teamwork, methodology, value and participation. Science is getting bigger and bigger. It's still also international. Following a scientific approach, this is a very important aspect. Should be open. Pattern recognition. Doing science together. Also understanding scientific workflows. That's very important. This was what Manolis tried to describe us in his presentation. So collaboration is getting bigger and bigger. Doing science together. Very interesting. Thank you very much for participating.
So thank you, Claudia. So thank you for participating in the Menti. So it shows that we already have quite some experts here, and but nevertheless, we hope that our session will be interesting to you. So the question, what's in for citizen scientists, is very important because it influences everything. As you know, the collaboration between citizens, so citizens, participants, and researchers can be very manifold. It can range from a very active engagement in scientific activities throughout different stages of the science process. And it can, on the other hand, also be reduced to very specific tasks, for instance. And therefore, the evaluation of the project goals and the outcomes can also be manifold as the goals and the outcomes are. So the evaluation has always has to be tailored to the scope and the goals of the project. And the question at the center of the evaluation is then also what's in for citizen scientists. And this is not only important for the evaluation, but for the entire setup, for the entire design of the citizen science project, because the question is key, because if it's not clear what participants can gain from their participation, why should they come in the first place and why should they stay? So in terms to make them to motivate them to join and to stay on and to contribute further, the question is very relevant. As you probably know, there are different types of collaboration identified in literature, and that's one of the most commonly used one. So there is a co-created type of collaboration where citizen scientists collaborate with researchers in all stages of the science process, from setting the research question to developing methods and materials, to collect data, analyze data, and even share results. And there is a collaborative form where participants are engaged in different stages, but not from the very beginning. So they might join at a bit later stage. And then there is the contributory type, where it's mainly about collecting or processing data. And we can say in Reinforce, our citizen science projects are somewhere in between collaborative and contributory, because our citizen scientists do analyze data, to categorize data, and might even be involved in sharing the results in co-authored publications, for instance. So that's something yet to come. But before I dive into the evaluation design, I want you to get a glimpse of what our participants did actually. And I'll hand over to Enzo for now. So to guide us through, to give us a live demo of the Deep Sea Explorers project as one of our 4. Enzo, the floor is yours. So I'll stop sharing here and I'll allow you to share the screen.
Sure. Okay. Okay, can you see what I am showing to you?
Yes, thank you.
Great. Hi, everyone. I am Enzo. I am currently working as a research engineer at APC, which stands for Astroparticle and Cosmology Laboratory, which is located in Paris. I am currently working in the field of bioacoustics using deep learning and machine learning methods within, of course, the Reinforce project. And today I am going to show you the demonstrator of Dixie Explorers project, which has been already introduced, which is therefore a sub-project of Reinforce I am working on. So before diving into the presentation of the demonstrator, let's talk about the main goal of this project. So this project takes place in the context of KM3Net, which is a neutrino telescope consisting, as you can see on this image, of an array of detectors, which is placed at the bottom of the Mediterranean Sea. And the main idea is to detect the presence of neutrinos. So this is possible because when a neutrino with a high velocity is traveling through the water medium, if it interacts with the water molecules, it will emit, as you can see here, a blue light. Added to this astrophysical, let's say, detection, we have also the ability to detect the light coming from bioluminescent species, as you can see here. So we have two kind of signals for the light. And added to that, we have also 3 hydrophones, which are placed as well at the bottom of the sea, which are in fact microphones. And with these hydrophones, we are able to record the sounds emitted by species diving toward the depth of KM3Net. So about 2,000 to 3,000 meters. And therefore, we are able to classify the different species based on the sounds they emit. And in the context of this project, we are classifying 2 different species, the sperm whale on one hand, as you can see here, and the short fine pilot whale here. So this is it for the main purpose of this project. Now let's talk about the demonstrator. On the main page, you have the banner in which you can find all the announcements, the major announcements. You have also some statistics about the number of volunteers at the moment, as well as the number of classifications which have been made up to now. You have also a sum up of the project, as well as external links with, for example, Facebook page, the Twitter and Instagram, etc. Then we can switch to the classification process. You have 2 kinds of data, as I have mentioned before. So let's start with the bioluminescence part. You have some graphs we want you to classify. Here, these are snapshots of light emitted by either the interaction of neutrinos or the bioluminescent species. You have, of course, a tutorial to help you in this classification process. It will guide you through that process. And the idea here for the bioluminescence part is to count the number of peaks. So either 1, 2, multiple peaks, or weird when you cannot find any peak in the figure. Then we can switch to the bioacoustic part. In this part, it is there are more graphs. As you can see, we have the waveforms, so the sounds emitted by the species, as well as the polar spectrum. You have also the tutorial here to help you in this classification. And the idea here is to determine if it's a sperm whale or a short fine pilot whale, or neither of these species, or just simply some noise. So I can see there is also a file guide. Maybe I could show you if I go back here. Apparently not. There is also a file guide on the right side of this window where you can find many examples of, for example, sperm waves to help you in the classification process. So apparently we cannot see it here, but normally you have it. Then there is a talk section within which you can ask all the questions you have. I try to answer as fast as possible to all the questions. You can also make some suggestions, share your thoughts, or share your results, etc. There is also some topics, some section about some collections of data if you want to look at, and some recent events which have been classified. And finally, let's go back to the About section I have showed you before, where you can find information on the physics. So what is a neutrino, what is the K-infinite telescope, etc. You have also information on the team members of these projects, some results with statistics of the first phase, since we are at the moment in the second phase of the project, and access also to application of augmented reality to look at the telescope by yourself, and of course an FAQ for the frequently asked questions if you have any. So I think I have covered most of the aspects of the project. So if not already done, do not hesitate to join us, and we will be glad to welcome you. Thank you for your attention. Of course, if you have any question, feel free to ask, and otherwise we will go to the next topic.
Thank you, Enzio. This has been very clear. So if you have questions, then also in the audience, you can put them in the chat and we will answer them as soon as we see them, or towards the end of the session. So I'll try to come back to our presentation. So I'll share my screen again. So let me see. Okay, again, I have to switch the screen, so it should be working now. So let's talk about evaluating citizen science project, a model that we use and that is in our experience working very well is the so-called logic model by Kurtz and Kubek, because it helps us to structure all the evaluative dimensions. So we have here the inputs, so everything that we invested in the project, personal efforts, time, money, materials, and so on. And we have the outputs. So what do we offer in our project and the people we reach? So outputs could be this universe projects that you have seen now. It could be workshops, it could be trainings, it could be webinars, and so on. And then we also want to observe how is this output used. So in terms of numbers, how many people do we reach and how do people like it? And then we have the outcomes. So what do we want our project to achieve within our target group? So would they develop new skills? Would they develop new knowledge? Would they increase their abilities in certain field? Might they also change their actions, their behavior? Would the project even contribute to improving their living conditions? And this is again then differentiated from impact. So impact is on the longer term and is also on a broader level. So the contribution that our project attempts to make at the societal level and on the longer term. And with this model, we look then very specifically what applies to our, in this case, citizen science project. And we make a draft. And with this draft, we go to our research teams. So we spoke with the Deep Sea Explorers research team. We talked to the Witch Hunters research team and so on to make it specific and to validate it. So also the kind of question that we asked before in the Mentimeter, what's in for citizen scientists, that's something that we would then also discuss and then make a specific logic model for the citizen science project. And to give you a few examples, so the participant satisfaction, we said we want to know how our participants like this universe projects. And we also want to know the face-to-face and then later online events, how they like these events. So we also want to collect the feedback. In terms of new knowledge, skills, attitudes, and awareness, something that we agreed with the researchers, what would they learn in terms of knowledge is, for instance, that we expect that participants would comprehend the role of large research infrastructures. They would understand basic physics concepts. They would understand principles of machine learning and also have a basic understanding of methods of scientific investigations. In terms of skills, we expect that the projects, the citizen science projects, would increase data recognition and analysis skills and contribute also to critical thinking. And in terms of attitude, it's the awareness of science and scientific work that would be enhanced, and the notion of inclusiveness of science through this opening up of research infrastructures to the public and even being able to take part. Increasing awareness of the interaction with nature, especially in this demonstrators in the Deep Sea Explorers project. And yeah, on the social and economic impacts on the broader scope, we agreed that the project might contribute to the literacy of the society, the science literacy, and further contribute to public understanding of science and critical thinking on the long term. So the next step then, after agreeing on the specific logic models, was then which instruments, so how to measure it. So the translation from evaluative dimensions to instruments capturing this evaluative dimensions. And we developed quite a range of evaluation instruments. We have an event monitoring sheet. We have developed a feedback survey. And for the participation on Zooniverse, we do have the access to the Access Zooniverse data. We do have a Zooniverse experience survey. And at the very heart of our evaluation is an online survey, a pre-post questionnaire to detect especially what citizen scientists gain from their participation in terms of knowledge, skills, and attitude. And for the broader scope, we relied on a self-assessment framework, which I'll share in a bit. We have first results available from our Zooniverse experience survey and from our self-assessment focus groups that we did with the 4 demonstrator teams. And if I will also briefly show you then the online survey pre and post questionnaire, how we set it up. But the results that we can share today is the Zooniverse experience survey and the self-assessment. And more results we will be able to share later in the project and also at the various conferences like the EXA conference in Berlin. So let's look at the Zooniverse experience survey. So this was to understand the participant satisfaction with the Zooniverse project. It's a very short questionnaire. This was the link was posted directly in the Zooniverse project. Maybe you have even noted it before in the live demo in the banner above. So it's only 7 questions followed by an open question with the question, do you have recommendations for us? And this is really used as an instrument for formative evaluation. So we collect the answers every 3 to 4 months to feedback then also to our researchers. So they still have the possibility to change things in the Zooniverse project if it's feasible and if it's doable. So looking at the results, here you see an overview of all of our 4 demonstrator projects: Witch Hunters, Deep Sea Explorers, New Particle Search at CERN, and Cosmic Muon Images. The answers, the number of answers are quite different also because they started not at the exact same time. So we have fewer answers, of course, in the projects that started a bit later, and more answers in the case where projects started earlier. What is interesting to see is also the demographics of our participants. So one criticism that is often raised against citizen science is that it shows again a typical pattern of male, white, well-educated people mainly participating in citizen science projects. So the question is really, is it really democratizing science, or is it just a repetition of a pattern that we already have in science? So there are various strategies available to really open up science. And we can see that in deep sea explorers, fortunately, the gender balance was good. So we even have slightly more females and males, but the numbers have to be interpreted with caution because yeah, the numbers are still low, but that's something that we observe also. While in the other 3 projects, there is the tendency to attract more males than females. So a pattern that is very much known in citizen science, especially in physics and astrophysics also. This pattern is not repeated if it comes to age. So that's interesting then that in all of our 4 projects, we have people of various ages. So we have people who are very young, and we have even people above the age of 80. So that's something that's quite unusual, and where our project has been able to attract various age groups. And also in terms of level of education, so we asked them also what's the highest level of education that you have completed. And also here we can see that there is people with the various highest educational degree. So again, the typical, or let's say stereotypical pattern of citizen science is not true for our 4 demonstrator projects. So we have people with only primary education and quite a few with secondary higher education, vocational training, then of course also academic degrees, bachelor degrees, master's degree, and advanced degrees like a PhD. If we look then at the results of our 7 questions here, you can see an illustration of the results divided by or compared by gender. There is just one significant difference between females and males in the answer pattern, as I'll show you in a bit. And overall, yeah, in the remaining items or questions, there are no significant differences, and overall the pattern looks very positive. So on a 5-point Likert scale from 1 to 5, very high scores our participants gave to the question or to the statement, I enjoy taking part in the project. So they really like the Zooniverse project. And also in the second one, I feel confident to contribute to the project. So they can really relate to what is demanded from their side. The third question, I find the project task difficult, is medium, and that's ideal. And why is that ideal? Because from motivation theory, we know that if tasks are too difficult, then people get frustrated and they are bored, so they will not continue their involvement. And if tasks are too easy, the same happens. So because they are not challenged. So a medium score here is an ideal case. And here in item 4, I do personally benefit from participating in a project is also rated quite positively. And that's the only gender difference. So females tend to acknowledge a higher personal benefit than males do. The fifth one, I find that the project is useful, has been rated very positively, again, by both genders. And also my contribution to the project is important for the success. Project success is perceived as very positive. And also most of them plan to continue contributing to the project. So this was a brief glimpse of our first results of the Zooniverse experience survey. Now I would like to talk about the self-assessment framework that we have used. It's a framework that has been developed by Barbara Kieslinger, Teresa Schäfer, and Claudia Fabian, and has been applied to various citizen science projects. And it's very useful because it also brings the different evaluative dimensions together. It's the model differentiates between the scientific dimension, the citizen science dimension, the socio-ecological dimension, and these at different stages of the citizen science project. So at the process and feasibility, so more at the implementation stage, and then the outcome and impact stage. So what's the legacy of the project, let's say. And based on this model, colleagues have developed a questionnaire. Again, this was done in a Lime survey tool that's capturing these different dimensions and the interlinks between these dimensions. And what we did is that we set up a focus group with the different research teams, so also the Deep Sea Explorers research team, for instance, where we went with them through the questionnaires and asked them to agree on a rating. So it was they also showed us why they gave the rating. So they had to agree, for instance, on a 5 and explain why they chose this score. When we look at, because our question for the session is what's in for citizen scientists, and this is just an exemplary finding of this self-assessment focus group, then in the case of Deep Sea Explorers, our researchers said that they were quite happy with how the processes and feasibility were set up in the project. So in terms of target group alignment and involvement, the options for involvement of participating citizens were rated as attractive on a 7-point Likert scale with 5, that's quite positive. Also, variety of options were available for the citizens, while the citizens could not choose to participate in all of the different stages of the project. That's again the typology of citizen scientists collaborating with researchers that I've introduced in the beginning. Also in terms of support, training, and communication that's offered to our participants, the research team was quite happy. So the project objectives are clearly formulated, the different roles and responsibilities are very clear. And so has just shown you before how it's also described on this Universe webpage. And citizens can also interact and communicate with scientists, for instance, on this talk page that he also showed. We do have several training measures and support materials, but it's done in a way that's as inclusive as possible and not specifically target to different age groups and different languages. That's why here we have a lower score here. In terms of outcome impact on citizens, our research team in Deep Sea Explorers gave very high rates. So they expect their participants to learn quite a lot in terms of knowledge, skills, and competences. And they also expect that participants gain ownership and responsibility for the project goals, and that the project might even contribute to a personal change in behavior among participants. And also in terms of engagement, they perceive that participants are really motivated and want to continue with the project activities. So this was an impression from the self-assessment focus group. We do this 2 times. So we did it after a month of the implementation of the project, and we'll do it again towards the end of the project also to see changes. And in the first moment, it's then also again used as a formative evaluation tool, because it makes research teams reflect about what's going well, what's not so going well, with still the possibility to change things. I've talked previously also about the pre-post questionnaire. That's an instrument that it's at the very core of our evaluation design, but we do not have results yet. So I'll just share how we set it up, and maybe you would like to find out more in a later seminar that we do, or at the conference presentation. We'll of course also share then the deliverable once it is available. So in the pre-post questionnaire, we want to find out what participants actually learn. So we have several items that relate to attitude towards science, for instance, with items such as enjoy reading about science-related topics. We do have statements, items for measuring the motivation for participating in citizen science project. For instance, because the topic is really important to me. We have several relating to science skills. I currently have the skills necessary to interpret the meaning of data. And we have also items for self-efficacy in relation to skills. For instance, I feel confident about my ability to explain how to do scientific activities to others. And then we have, and this is very specific to every demonstrator that we have, in terms of knowledge, we have questions like, I would know how to explain the following terms in simpler words. And here we have some general terms, and then also some terms that are very specific to the demonstrator. Then we also ask how they access the Soniverse project, and also some demographic data. So that's a screenshot. It's again a Lime survey. It's quite a long a survey, or comprising one, but yet not so long that it disencourages people from participating. And it's again, the link is on the Soniverse project, and people are encouraged to fill it in when they first log into the Soniverse project. And then a month later, we send out via email the post questionnaire, so we can measure the difference between the first interaction with the Soniverse project, and to see how it evolves over a longer period of time. So now this was the input basically from our side. I would now hand back to Claudia, since we still have time, for a last question on the Mentimeter, and then maybe we still have time for a couple of questions and answers.
Yes, I have shared again the link for Mentimeter. Please access it again and check it out. If you still have the question, what do you think that volunteers can learn, then please go to next question. And then you should get the question, what recommendations would you give to policymakers to encourage the implementation of citizen science projects? Please share your thoughts with us.
Now that you also have listened to 4 sessions, we would be very curious what your arguments would be, or what kind of recommendations you would give to policymakers to to further encourage the implementation of citizen science projects.
Could you also share, Elisabeth,
Oh, am I not sharing?
No, you're still in the presentation mode from the other one.
Oh, sorry. Let me see.
Maybe we get some thoughts already.
Is it working now?
Yes, we can see it now, but there are no recommendations yet. Improve science communication. Okay. Please let us know what you think. Everything is anonymized. You don't have to be scared of that we show it. Make more funds available. Yes, very important aspect. Trust openness and support for fair data and approach. Take part in the CS project themselves to experience the benefits is a very good comment, because this was our first exercise actually, because we thought mainly researchers are doing this project, but they are not volunteering themselves on them. I would suggest to encourage a citizen science work package. That's very good for every scientific-driven research and innovation project. Very interesting. Any more thoughts? Maybe this is a little bit input for you, Francesco. Also recognizing this researchers' motivations for CS is a research tool. that citizen science is not just a public engagement activity. Yes, that's absolutely true.
Yeah, I would also add a repository of success stories and best practices for citizen science.
Mm-hmm. Have you entered it in the Mentimeter, because we collected there?
I will now.
Thanks, Francesco.
And while maybe some people are still entering recommendations, we also have time for questions. So if you want to ask anything or comment.
There was one for Enzo. It is written in the chat. What is the dead time due to bioluminescence in your detector? Enzo, can you answer this question, please?
Yeah, unfortunately, it was a question related to the bioluminescence data, and I was working on the bioacoustic data. It was more focused on astroparticles, so unfortunately, I am not able to answer, sorry, to be useless.
But you could maybe ask when she can access the YouTube link.
Yeah, sure, I have sent her a message directly.
So for everybody who asks this question, don't worry, you get an answer at the end of the day, at least. Yes, to include citizen science project and research and innovation projects. There are some quite interesting ideas.
Here is a question in the chat. Do you also investigate how deeply the citizen scientists are involved in the demonstrators when you analyze the questionnaires?
I could help answer that if you like.
Pardon?
I could help answer that if you like.
Yeah, please go ahead, Manolis.
The only thing that I would like to add here is that we have a monitoring mechanism which can tell us how long, how much time the citizen scientists have engaged, let's say how much time they have invested in working with the demonstrators, as well as how many actions they have done. Of course, this is all anonymized, and we are not using personal data. So this way, we are able to understand the individual and the total contribution. I know that you are mastering before.
Yes, it was difficult to understand you, Manolis, but you just said that you have the time, how long the citizen scientists stayed on the exercise, on practicing the categorization. Can you tell us the average time, maybe?
Yeah, we have both the means to understand the average time per citizen, let's say, as well as the average time per project. We are able to understand, however, how deeply a citizen has engaged with the demonstrators. And also, we are able to monitor, let's say, also the other actions, how engaged they were in the discussions, and the other activities flanking, let's say, the key actions of the demonstrator.
Yeah, the question is then also, what would deeply exactly mean? Is it the number of classifications and also how long they stay on board, or is it something else? So it's a matter of also definition, but what we do is that we link our pre-POX questionnaire to the access data. So we then also can see how long participants stayed on board and how many classifications they did. So if we define the deepness of involvement or engagement with this, then we definitely have will analyze this. So also to see whether it correlates, whether, for instance, the advancement of knowledge or change of attitude has anything to do with how much time they spent on the project. Maybe it doesn't, maybe it does.
Yeah. And it's not only the categorization of the project, it's also how the people are involved in this talk page, because the researchers told us that the discussions are quite active there, and some of them are communicating with the citizen scientists on a daily basis. So this is also a kind of involvement although they maybe don't do the categorization, but they deal with the topic and they like to share their thoughts with the citizen, with the scientists, with the researcher. Here is also another recommendation. I cannot read it. Yes, development needs to continue to include citizen science explicitly in order to make sure EOSC has curated accessible interfaces for non-specialists. Interesting.
May I add something, please?
Yes.
It is very important to understand that the way citizens engage in a citizen science project is, you know, let's say that it has its own characteristics. For example, there are people who might be very interested when something new comes up, and they may do many activities for a day, many classifications, let's say, and then they leave. There are people who have a sustained participation and thus a higher loyalty to the activities, the project itself. So all these factors are taken into account in order to understand. And of course, one's motivations always change over time. And this is part of the very hard work that Claudia and Elizabeth are monitoring and trying to help us all understand. Because in the end, what we want is to make the projects more relevant and more engaging to all, and to help keep our community motivated. Yeah.
Thank you, Manolis. So I think we can slowly close the session. I do not see any more questions or comments in the chat. Thank you very much for participating and also for interacting with us on Mentimeter.
Yes.
It was really nice, Elizabeth. I can add something on my side because I'm the one that wrote down the suggestion of incorporating and merging the citizen science driven task, work package. Maybe it's a long shot at the moment. If not in every research and innovation project, at least in the one with the more scientific purposes for the general public, I would say. I saw someone else kind of wrote the same thing, so it is starting to be a more common general feeling. Because I come from a very from background of communication, so I see a similar. We are still at the early stages, but I see kind of a similar pattern of what happened with the communication and dissemination task back 10, 15 years ago. They were not part of they were pretty neglected, but then now the communication dissemination, whatever they are called, are part of every project with a dedicated work package. And maybe the same thing are going to be happening for the citizen science effort as well. Yeah.
Yes, I agree. And we also
may I add something here? One last thing based on what Francesco said. One needs to take into account that in terms of funding, what is most important both for research funding agencies and for research performing organizations is sustainability. Sustainability. A citizen science project which keeps going beyond the funding of the project, funding duration of the project, because this is what we are discussing about, can have added value in the process. So we go beyond communicating the project itself, and we create, let's say, sturdy, how can I say, hubs where citizens can actually keep working beyond the duration of a project. And this is to us very, very important.
Yes, but this is also mentioned in the Soniverse experience survey when we got some feedback that we need to provide a kind of certification that the people could show the others that they contributed to these demonstrators and that they are engaging with scientists. And this is we need to show how we acknowledge their contribution through a certification or on the website showing their nicknames. We still have to figure that out because this is also a kind of education, as you said in your presentation.
Okay. Thank you very much again, and I'll hand now back to Francesco Mureddo.
Yes.
And I stop sharing here.
Thank you very much. From my side, I just want to thank the audience and that is following us in the webinar on Zoom and also in our YouTube channel. And of course, I'd like to thank my fellow speakers and partners of the project or in other projects like Ville. For what concerns the workshop, it has been recorded and it will be shared on YouTube and through the social channels of the project, social media channels of the project. And the next event, which will take place live in Pisa, will be about the exploitation of the roadmap and the development of the roadmap itself, and it's gonna take place on the 1st and 2nd of September 2022. So more info to come, and please keep following our projects, and we look forward to continue interacting with you all. Thank you very much to everybody.
Thank you.
Thank you.
Everybody,
Bye.
take care.
Bye bye.
See you soon.
Thank you.